Ready to tackle some fractions? Okay, when you see a linear equation and it has fractions in it, if you don't like the fractions, you can ask them to go home, and you can do it politely. Okay, say that they are not invited to this particular math party. Okay, so what we want to do, we want to find the least common denominator. I'm looking at 6 and 8. What is the least common multiple of 6 and 8? Well, it's not 8 because 6 doesn't go into 8. So think about the first multiple of 8, 16. Does 6 go into 16? No. So what's the next multiple of 8? That would be 24. Does 6 go into 24? We have a winner, okay? So I have identified my least common denominator to be 24. All right, now what I want to do with that, I want to take and multiply each piece of the equation by 24, okay? I'm going to multiply both sides of the equation by 24, but we're going to actually take that left side and multiply each piece, which we would have to do anyway. Okay, this is what it looks like. When I multiply each piece of that equation by 24, this is what it should look like when you set it up. And you want to take the time to set it up correctly, right? Because what's going to happen is by choosing a common denominator to use, we're going to actually see the denominators disappear, okay? Watch how that works. This is the same as 24 over 1. But I'm looking at 24 over 1 times something over 6. Well, remember that when I'm multiplying fractions, I'm multiplying the numerator times the numerator and the denominator times the denominator, okay? So I can think about this numerator over this denominator, and I can simplify this fraction. You know what 24 divided by 6 is, right? Okay, this will just be 4 now. Now if I look at this one, I've got 24 over 1 multiplied by 2x minus 4 over 8. Again, I can think about this as 24 divided by 8. And you know what that is. Okay, so now this has become 3 and this has become 1. And then on the back end, I don't have any fraction to deal with, so I'm just going to leave it alone. Now I'm going to rewrite this without the denominators because they're gone. See, 1 times 1 and 1 times 1, and that denominator of 1 doesn't impact us at all. So our resulting equation looks like this. 4 times 2x minus 2 minus 3 times 2x minus 4 is equal to 24 times 9. Now we're back to what we were doing before. So I can distribute the 4, distribute the negative 3, and multiply this out. Give that a shot. Okay, so now I've gotten rid of all my parentheses. And what's left is this. 8x minus 8 minus 6x plus 12 is equal to 216. So now I can combine like terms here on the left-hand side and see what happens. On the right-hand side, we're very simple already, so we don't have to do anything over here. Let's just combine the like terms. Pause that video and see how you do. All right, here we go. 2x plus 4 is equal to 216. Subtract this 4 to the other side and then divide out the 2. So we would end up with 2x equals 212, and when we divide out the 2, we would end up with x is equal to 106. Actually, when I sub that in here and here, I end up exactly with 9 is equal to 9. Voila! Math magic at its finest. Let's do another example like this. Okay, here's another example. X plus 1 divided by 3 is equal to 5 minus x plus 2 divided by 7. Take a look at those denominators and see if you can determine what the least common denominator would be. What numbers am I considering? 3, 7, 5? Not the 5, because 5 is not a denominator. I just need to think about these two. And the least common denominator is going to be 21. Now, take a second and rewrite the entire equation so that each piece is multiplied by 21. Here, here, and here. Okay, so 21 times this piece, x plus 1 divided by 3, equals 21 times the 5, minus 21 over this piece, x plus 2 divided by 7. Now let's go ahead and clean things up and get rid of those denominators. Okay, when I look at this first piece, the 21 divided by 3 is the same as 7 divided by 1. I don't need to do anything here, but when I look at this second piece, the 21 over 7 is the same as 3 over 1. And so now there are no denominators left. Let's rewrite it. Okay, rewritten, this is what it looks like. 7 times x plus 1 is equal to 21 times 5 minus 3 times x plus 2. All right, get rid of those parentheses by distributing any coefficients. All right, what this is looking like. 7x plus 7 is equal to 105 minus 3x minus 6. Okay, we're going to combine some like terms on the right-hand side just to make things a little bit more clear. Just so it makes things a little more clear what we need to do. All right, 7x plus 7 is equal to 99 minus 3x. Let's push this negative 3x to the left-hand side by adding 3x to both sides. And let's get rid of the 7 by subtracting 7 to both sides. All right, 10x is equal to 92. Okay. So now just divide through it by 10. All right, when I divide through by 10, I get 92 divided by 10. Now that can be simplified at least by 2. If I divide out a 2 on the top and the bottom, I get 46 over 5. And that's as far as we can go. That's a good answer, 46 divided by 5. Now you could also write that as a mixed number. Do you remember how to do that? Divide the 46 by 5 and it goes in 9 times with 1 left over. So it would end up being 9 1/5. All right, and then I could also think about it as a pure decimal. As long as the decimal terminates, it's good. Okay, so this is the same as, so that's the same as 9.2. If you took and divided this on your calculator would say 9.2. That's okay. Now, if you divided it in your calculator and your calculator said 9.2174396, you cannot write 9.2 unless you're asked to round, okay? Simplified fractions are better in that case, but if you have a terminating decimal, that's okay. Okay, last of these kinds of examples. We have, again, a lot of fractions, a lot of numbers in the denominator. Can you tell me what the common denominator is? The least common denominator is even best. Okay, we have a denominator of 3 and 2. Our common denominator here is going to be 6. All right, you know what to do. Take a second and multiply each piece by 6. Okay, when I do this, you ready to cross some stuff out? Take a look at what fractions can be simplified. I have 6 divided by 2 and 6 divided by 3 and 6 divided by 3. All right, the 6 divided by 2 became 3 divided by 1. And both 6 divided by 3's became 2 divided by 1. Let's rewrite and see what we have. Wow, that really simplified things. I am left with 3 minus 2p is equal to 8. Subtract this 3 to the other side, and then we'll divide by negative 2. Negative 2p is equal to 5, and p is equal to negative 5 halves. Okay, in the last video, I'm going to show you how you can use your graphing calculator to solve linear equations. It's not going to be on the whiteboard though. I'm going to use actually the graphing calculator. Ready? Here we go.